This is our smart public outlet. There is not currently a solution for public vendors to use electricity on the streets because building owners have no method of tracking how much energy is used, and no way of charging people for their energy use. Our public outlet offers a solution to this problem, allowing building owners to both make money and monitor energy use of public placed outlets, and giving an electrical option to street vendors who would otherwise be forced to use gasoline generators.
Our architecture focuses around a REST API running on our server. That means that no requests are ever sent to the device, the relay, or to the phone. All requests are sent to the server, which then returns the state that the relay should be in. For example, if we go through pairing the phone with the NFC chip, a request gets sent to the server, and the server stores the user ID and the chip identification code. Then, if the user taps on the outlet button on their phone, a request is sent to the server to enable it to be ready for the NFC tap from the relay. So the server is then in the ready state. Once the request is sent from the relay to the server with the card ID, it verifies that those two match and then returns to the relay the code that it should turn on. The relay then continually updates the server with the energy usage, in which case the server notifies the relay if any credits have been added and when it should turn off.
So our device has a place to actually input an AC power cord from the device we're trying to power, and is powered directly from an AC output of a wall. We then take that AC output and have a AC to 5-volt DC converter on board, which is then used to power our entire system. After that, it then goes through the relay, which is turned on and off from the feather facade using a digital output pin after initialization and authorization. And then we measure the current running through the relay using a current transformer. Now the current transformer steps down the current running through that line by 1,000. For example, if we have 3 amps running through the line, we'll see a 3 milliamp current running through the resistor that we have at the end of it. The resistor we use is a 200 ohm resistor, so when we have a 5 amp current running through that 200 ohm resistor, we have a maximum of 1 volt, which is the maximum of the ADC that the feather facade has. We're then able to take that current from the voltage that we get. That's a linear transformation between the voltage and the current. We take that, which is a non-RMS current, we make it into an RMS current by multiplying it by 0.707, and then take that, multiply it by 110 volts of the wall, assuming we have a resistive load, and then are able to measure both the power and the energy, knowing the amount of time it took to actually take that measurement. Because the measurement is AC, it doesn't happen instantaneously, so we take a ton of samples over a period of about 100 milliseconds and grab the max value from there.
The operation of the device is simple. A customer using the service would be given an NFC card and an account. They then pair the card with their phone and given their user code that is associated with their account, they would then send that back to the server, and the server has now paired that card code with their account. The phone is ready for pairing. So the user will click the button on the app saying that they are ready to pair with the outlet. They then take their card and tap it to the outlet itself. The outlet then sees that the card was there and sends the ID of the card back to the server. If authorized, it turns it on. It is now reading the energy consumption of the device, in this case, a lamp. It is doing a time estimate based on a moving average of the energy consumed at a certain time, and it is taking the energy left based on the credits that are associated with the account that is paired with the outlet and decrementing them using the energy that is consumed. There are 3 ways to turn off the device. 1, the user can turn it off manually from the app. That turns off the device and unpairs from the account. Another way to turn the device off is if somebody unplugs or turns off the device for a 10-second period. The outlet will recognize that the energy being consumed is not changing and that the energy drawn at any given time is 0. After a 10-second period, it will turn off and disconnect from the user. After a repairing process again, we can turn the outlet back on. As we can see, it decrements the energy left in the account in addition to on the screen, and when the energy left hits 0, the device disconnects and turns back off.